I'm really excited about this lesson. For today, we are all scientists. Everything that we do in this class now needs to be able to be understood through the spectrum of a scientist, and we have to answer it in the way that a science teacher would want it answered. So if you notice right away, in this term right here, all of a sudden we have times 10 written as an X. We do that because science teachers want multiplication symbols as X's, even if math teachers don't. So for this lesson, treat it the way you would treat it as a science teacher would. So we are learning about scientific notation. The word notation is important here. What it means is how you are noting something or how you are writing something. So this literally means scientific writing. So we are going to be writing numbers the way that a scientist would. So scientific notation looks like this form right here. Something point something times 10 to a power. So for example, I could write this as 3.9 times 10 to the 8th. That would work. I could write this as 6.2 times 10 to the negative third. And immediately, when you are asking, why did we learn negative exponents? What is the point of negative exponents? This is your answer, scientific notation. So let's look at an example. 6.3 times 10 to the 6. Well, this is pretty close to what we just did, but it's not exactly the same. If we look at this term right here, what that literally means is 6.3 times 100,000, because 10 to the 6th power is equal to 100,000. So in this problem, we know that you would then multiply times 100,000. That means you're going to move your decimal point to the right 6 times, in this example. Oh, there should be 6 zeros. Hopefully no one missed that one. So you'd move it to the right 6 times. So we can shortcut that process by looking at this exponent right here. It literally tells us move the decimal 6 times to the right. So I take my number 6.3 and I move 1, 2, 3, 4, 5, 6. And I insert a 0 for all of these numbers. So in this case, my answer would be 6,300,000. So already that's the question. Why are we learning scientific notation? Well, scientific notation is used to write really big numbers and really small ones. This problem here, same form written as before, but now we're doing times 10 to the negative 4th. Well, that means that it's times 1 over 10,000. Well, when we are dividing by 10,000, that means our number is getting smaller. We're moving it to the left. So positive exponents make big numbers. Negative exponents make small ones. So for this problem, we are going to take our number and we are going to move it to the left 4 times. And our answer to this problem is this. Very, very small number. So scientific notation is used to write really big and really small numbers. Positive exponents tell you how many you should move the decimal point to the right to make a big number. Negative exponents move your decimal point left, and they make very small numbers. So let's look at a couple examples here. 2.83 times 10 to the 3rd. So in this example, we would take our 2.83. Positive exponent means we move it to the right 3 times. And our number is this. 2,830. Now, down here on the bottom, we have the same idea, except now we have a negative exponent. Negative 4 means we move our decimal point 3 to the left. So we get 0.000422. And that is exactly what scientific notation should look like. Now, there's one note that I want to make here right away. The number in front of that decimal point must be, less than 10, but more than 1. So, for example, this number could not be written with the decimal point there. This is not correct because the number in front of the decimal point must be more than 1. On the same token, I could not put the decimal point there and say that. Whoops, positive 2. That is also not correct because the number here would have to be less than 10. So remember, the number in front of the decimal point greater than 1 or equal to 1, less than 10. I'd like you to try these two on your own and see how they go. For this first one, we end up getting 4,230,000. For the one on the bottom, that decimal point moves to that left 4, and we get that number. If you are struggling with this concept, make sure to come and talk to me so we can work through some examples together. So, if you need any help on actually building the problems here, one of the best things to do is to, once again, we need to be between 1 and 10. So I want to put my decimal point in a place that would make a number between 1 and 10. Well, I notice my decimal point can go right there. I can ignore those zeros, so I create 3 and 4/10. And I go times 10 to the, and I have to decide which direction should it go? Well, this is a big number, so I need a positive exponent, and I count 1, 2, 3, 4. And that is my correct answer. If you're ever unsure if you've done it right, one of the best things to do is simply redo the problem like you would have before. So I go here and I move it 1, 2, 3, 4, and I get 3 zeros. Same thing as what I started with. So down here on the bottom problem, same thing, I got to put my decimal point in a place that creates a number between 1 and 10. So my decimal is going to go right there. And so I create 2 and 34/100ths times 10 to the, well, this is a small number, so I need a negative exponent this time, and I count 1, 2, 3, 4, but this time it will be a negative 4. Try these on your own. Right here, I put my decimal point right there, and I get 1.8 times 10 to the 6th power. For this number down here, my decimal point goes right there, 2 and 45/100ths times 10 to the negative 5th this time. If you have problems on any of these, once again, come talk to me. We'll work through some examples together. And finally, we've gotten to this problem where we can start to do operations with the numbers that we're working with. Well, what I would recommend first is to turn both of these into regular notation. There are shortcuts that exist, but I would think that doing regular notation first and then learning the shortcuts second would be a good plan. So I end up doing this number times this number, 14,000 times 7,600. Now, it would entirely be possible to work this out by hand. But since we are working like scientists, I will allow you to use a calculator as long as you come to me and say this phrase. I will let you use a calculator. If you are one of the people who do not watch this video and you do not learn this phrase, you have to do these problems by hand, which would be very, very difficult. So if you have classmates, you should probably remind them to watch the video. Times 7,600, and I get that crazy number. So what I'm going to do is I'm going to put my decimal between the 1 and the 0 right there, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So it's 1.064 times 10 to the positive 8th power. Huge, huge number. Writing out all those zeros would not make sense. So this is going to be a much easier way for a scientist to write that number. Why don't you try this one on your own, and as long as you have said the numbers are insane, you can use a calculator. I end up getting 2,300 and 180,000. We multiply them together. Get that crazy number, so I go 4.14 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 again. Now, if you would like to learn the shortcut on these problems, I would be more than happy to teach it to you, but I would like to do that on an individual basis. So if you'd like the shortcut, come talk to me. Otherwise, you should be ready for the assignments. There are 4 assignments available for this section.